Many analyses require the use of statistical and machine learning methods. Material in this supervised learning chapter of Modern Data Science in R is intended to provide an overview of what's a really important, fast growing area. This is clearly one of those places where multiple courses, multiple books can be provided on this really important topic, but we really wanted to provide an overview in the series of some case studies that can be used to describe these methods. And the methods we're talking about and really introducing include logistic regression, decision and regression trees, random forests, neural networks, naive Bayes, k-nearest neighbors, ridge regression, and the lasso. We begin with an example and the materials available on the instructor site. Describe an example where data are read from census example where there's 33,000 observations, and we want to be going ahead and predicting income being above or below $50,000. And this is again supervised learning because we have observed that outcome. And we want to do that as a function of some of the other variables that are available. And this may be useful in a situation where we want to try to predict income, but we don't actually observe that. And so the example that we have available on the materials describes using, for example, just the capital gains that individuals have reported from this census data, and to kind of see that that actually provides a reasonable kind of cut, that those with higher capital gains tend to be in the higher income category, but it's not perfect. So then the question is, how can we start to improve those methods? And to think of various tree approaches and go ahead and include aspects of family characteristics, and this decision tree is described. And so this case study proceeds with all the other code available from the textbook to try to improve those measures in various ways, to go ahead and fit some additional approaches, to introduce the ideas of confusion matrices for this dichotomous outcome, the idea of area under the curve, and then finally concludes with a comparison of multiple methods that are provided in this figure, where a random forest, naive Bayes, k-nearest neighbors, and a tree model are compared against the null model. And you can see again there's slight advantages and disadvantages to each one. The chapter continues with another example using a quantitative outcome, but with similar kind of approach. And this is a good way to kind of bring in these methods into the course or other ways that you're thinking about this. In addition to these materials, we've made available the exercises from this chapter as an R Markdown